This call is now being recorded.
Okay, we are now on lesson 12 here in geometry, and we want to start with our discussion of something that you may have been introduced to, possibly in junior high. They're called transformations. And transformations really is a big word for you're going to be rotating things, you're going to be flipping things, and you are going to be seeing things moved right or left, up and down. And so we're going to talk about three transformations in particular. And so let's get started with looking at how your book approaches this. And so the first part of lesson 12 is like a quiz. So we're going to kind of bypass that and get right to the discussion part. So this first part is just a quiz that they have, a review that we'll talk about later. So we'll bypass this for right now. We'll come back to it later, because the real part comes in this discussion of sort of review of the idea of what are transformations, and let's take a look at them. So the word transformation has a special meaning in geometry. The transformation f of a plane, as it reads, is a function that assigns each point P of the plane, of that flat plane, a unique point. So it's basically a function. And so we've studied functions in algebra. And in this case, we're sort of thinking about transformations as a function. And so transformations preserve. What that means is it keeps the lengths of the segments and the measures of the angles. So that's really key to this, is that when we're moving things right or left, up and down, when we're rotating them or we're flipping them, that figure doesn't change in the length of the segments that make up the figure, and it doesn't change in terms of how the figure is comprised in terms of angles. And so it starts with some key ideas here. And that first part, transformations that preserve lengths of segments and measures of angles are called basic rigid motions. So we want to first of all start by putting that in here. Basic rigid motions. Now, it turns out these basic rigid motions are in effect what we're talking about today, transformations. It goes on to say there's a fourth one that you would have been introduced to. It's called a dilation. Now, a dilation is an example of a transformation that preserves the angle measure, but not the length of the segments. Dilation is enlarging or reducing. And so that second idea, a dilation, is an example of a transformation that preserves angle measures. Then, of course, it goes on to talk about, in this particular lesson, we work only with the rigid transformations. In other words, that first one we just talked about, the basic rigid motions. We are not going to be talking about dilations for right now. In other words, we won't be enlarging or reducing. We're just going to be moving. And so we call a figure that is about to undergo a transformation the pre-image, while the figure that has undergone the transformation is called the image. So in this case, we want to make sure we understand that that's the pre-image. And then, of course, after the transformation has taken place, it's called the image. So again, these are just some basic ideas. You've probably been introduced to these before. And the key is to understand that there's a total of 4 transformations, but we're only going to talk about 3 of them in this lesson. Okay? So here's what they look like. You can see that they use the figure of the R, the letter R, and you can see that in the rotation, you're basically just spinning this thing. You're rotating it, you're spinning it. A reflection is you're just obviously just flipping it. So we can think of a rotation as a spin. We can think of a reflection as a flip, another way to say it, and we can think a translation as just simply a slide. You're sliding it. So those are 3 words that we can associate with the 3 rigid transformations that we're looking at today. So a rotation is a spin, a reflection is a flip, and a translation is a slide. Easy concepts. So in particular, as we look to better describe this, there's some things that we want to talk about in each of these. First of all, for a rotation, we need to know the following things. We need to know, for a rotation, where is the center of rotation coming from? We need to know the center of rotation. We need to know whether it's going the direction, whether it's going clockwise or counterclockwise. So it's important to know what direction is it going. Is it going clockwise? Or is it going counterclockwise? And of course, the number of degrees it's rotated. So the other thing is the number of degrees, we'll put over here, the number of degrees it's being rotated. So that's really the key aspects of rotation. A reflection, it's important to write in here, a line of reflection acts as the perpendicular bisector of each segment that joins a given vertex of the pre-image with the respective vertex of the image. So let's write that in. So there's a line of reflection that acts as the perpendicular bisector of each segment that joins a given vertex of the pre-image to the corresponding vertex of the image. Finding it very hard to write on this thing, but that's all right. So repeat that, rewatch that, let it sink in. Now the last one, translation. Well, a translation, we need to know that the point P to be translated, any point, the length and the degree of measure of the angle that the vector moves is going to be the same. It's going to we're just sliding it over. And so the key here is that for a translation, the figure stays exactly the same. We're just moving it. It's just a move or it's just a slide. That's all we're doing. Figure is the same. We're just moving it. That's all we're doing, just moving it. Okay, so that's basically it. Take a moment and we're gonna finish this up with the idea of what are we asked to do. Make sure you kind of read over, the fact that what's a basic rigid motion, distance preserving and angle preserving. Okay, these are key ideas to what we're talking about with regard to transformations. And then finally, you're going to be asked in your problem set, you're going to be asked to take a look at two problems where you're going to be asked to determine the angle of rotation. And so what they're showing you here is a technique. You're going to need a compass. In fact, you're probably going to need even more than a compass. You're going to need a protractor. So a protractor, which I believe it mentions, is going to be necessary in order to measure the angle measure. And so here they just pick on any figure. And in this case, if you pick this point on the problem that we have for number 1, and they want to know what is that angle measure going from there to there. It's that angle of measure that they're showing from this point to that point, the same relative point on a figure, the same relative point. What is the angle of rotation there? And you can only determine that by using a protractor. So we'll kind of go from there. Remember, you can always go clockwise or counterclockwise. So you're probably going to have multiple answers for both 1 and 2. See what you can do on that, and we'll come back, talk more about transformations.